Hello. In this video, we will mention a few key points on the topic of momentum and impulse, and then we will answer a few past exam questions on this topic. Now, let's start from the definition of momentum. Momentum is the product of mass multiplied by velocity. It is a vector quantity, and every time that we work with momentum or impulse, we need to remember that we're working with vector quantities, so we need to count the direction, and maybe if we need to add or subtract directions, we have to consider this as well. Now, although momentum is an important quantity, the change of momentum is also an important quantity. The change of momentum is mass times V final minus mass times V initial, so it is mv final minus mv initial. Now, momentum as a quantity shows how easy or how hard it is to stop a moving object. An object that has a great momentum, it is quite hard to stop. Now, we continue with the concept of impulse. The impulse of a force is the product of the force multiplied by the time that the force acts. This is if the force is constant, or if the force is a non-constant force, then the impulse is integral from time initial to time final of force times dt, or equal to the area of the force versus time graph. Now, the impulse momentum theory, the impulse and the momentum are connected with the impulse momentum theory that states that the impulse J is equal to the change of momentum. So from this law, we can say that the force times delta t, it is equal to m v final minus v initial, which is the which is the delta v, and we already know that the force is equal m times delta v over delta t, because delta v over delta t is the acceleration. So from the impulse momentum theory, we can find a missing force or a missing time or a v final or a v initial. In a similar way, we can say that the force is equal delta p over delta t, or that the force is derivative of momentum. So these are the basic laws that we need to get familiar with in order to answer the questions related to momentum or impulse. Let's try to apply them with some questions. Feel free to pause and read the question thoroughly. Now, what we have here is we throw a ball towards a wall and we know that it bounces back, and if the conditions are ideal, then the reflection of the ball happens at the same angle. However, in the situation 2, the same ball is moving and it contacts a soft surface, so maybe there is some loss of speed, and indeed we know that the V2 is less than V1, so the V2 is the V final and is less than the initial speed, and because of this maybe the angle is not equal. So we need to figure out what is the momentum, what is the force from the wall to the ball on the situation 2. Now we know that the force is equal to the change of momentum, so all we need to do is subtract the final momentum and the initial momentum. Now the final momentum is a vector that is pointing 30 degrees under the x-axis minus the initial momentum. The initial momentum is a vector that is directed 45 degrees downwards. So we need to subtract these two vectors, and we remember that in order to subtract two vectors, we need to change the minus into a plus and change the direction of the second vector. So we need to add these two vectors, and if we add them with the head to tail way, we need to bring the start of the second vector to the end of the first vector, and the resultant vector is a vector that originates from the start of the first vector and finishes on the last vector, and we see that it is quite similar to vector c. So it is a vector that points to the right, but it also has a component upwards. So the correct answer is C. If you want, you can use the parallelogram method. The parallelogram method is that we make the two vectors originate from the same origin, and we try to draw with dotted line a parallel vector to the first one, then a parallel dotted line to the second one, and the resultant is a vector that is diagonal on this parallelogram. So in both ways we find the answer to be C. We can continue on the next question, where what we need to calculate is the change of momentum from 0 to t. And we remember that the change of momentum, okay, we can find it from mv final minus mv initial, but since we don't have this as a given, maybe we'll need to say that the change of momentum is equal to the impulse, and one way to find the impulse is to multiply force times delta t, but we said that we can only use this law if we have a constant force, and this is a non-constant force, it varies. So we need to say that the delta p is equal to the area under the force versus time graph. This is a triangle, so it is half the base is t and the height is f, and the answer is C. Then we have a free response question. Again, feel free to stop the video and read the question thoroughly if you want to. However, on the AP exam, it's quite useful to be able to scan the question and not really read it. Now, what we have is a force sensor, so the cart is probably moving to the right, and something measures the force, and also something measures the motion. And we can see it on the two graphs that we know something about the velocity and we know something about the force. So probably as the cart is moving to the right, it has a velocity. Now, he considers it's -2, so the direction to the right is negative, and the cart reaches the end of the rope, which is elastic, so later the rope pulls it backwards, and that's why the speed is to the opposite direction, the velocity is to the opposite direction. And this is happening because the rope applies a force on this cart. From the givens, we need to calculate the mass of the cart. Now, most likely, since we know velocity, force, maybe we'll use the law of conservation of momentum, so maybe we'll use the impulse and momentum theorem. So we can say that the force times delta t, or the impulse, actually the impulse j, it is equal mv final minus v initial. Now, the impulse, there are a few ways we can find it, from the force times delta t if we have a constant force, or since we have the force versus time graph, the impulse is equal to the area, and the area is 1 Newton second, the mass is unknown, and carefully the v final is 2 minus the v initial, that it is -2, so minus 2, so 1 is equal m times 4, and this means that the mass is 1/4, or 0.25 kilograms. Now he's mentioning that for part B, we consider that the time that the force acts is between 0.5 and 0.75 seconds, and the force can be modeled by a sine function. So the force is equal as 6.3 times sine of 12.6 t, and since the omega is given in rad per second, we need to make sure that when we do calculations in the calculator is set in radians, and we need to show that the graph is 1 Newton times second, so we'll say that the impulse, okay, it is equal to the area, but it is also integral from time initial to time final, f dt. So the impulse is from integral from 0.5 to 0.75, 6.3 sine of 12.6 t, and dt, and all we need to do is enter this in the calculator, and I'm quite sure we'll find something. Again, the calculator needs to be set on degrees, so I'm pressing shift mode 3 in my calculator, shift mode. And 4, so integral from 0.5 to 0.75, 6.3 multiplied by sine 12.6 x. The calculator will take some time, but I'm sure it will give a value close to 1. Indeed, 0.9997, so approximately equal to 1 Newton times second, and this is equal to the area, since the impulse is also equal to the area under this graph. For part C, we need to say that the experiment is repeated a few times with another chord that exerts a greater force, a greater average force. And the card starts and ends with the same speeds. So since we have the same speeds, we'll have exactly the same impulse. The impulse will be the same, and since we have the same mass, and we need to know that if the area for this graph will be greater or less. We said that the impulse is equal to the area, but the impulse is the same since we have the same speed, as the same initial speed, the same final speed, and the same mass. So it doesn't matter that the card applies a greater average force, the impulse will be the same and the area of the graph will be the same. Now the only difference actually will be that since we have a greater average force, and the two areas will be the same, it means that the graph will be narrower but with a greater height. So the same area because of the same impulse and the same mv final minus v initial. And for the last part of this question, we replace the cord with an elastic spring, and we need to find what is the maximum x max, the maximum displacement of the spring. Now, this is not related to the impulse, but it is a nice question that is related to the law of conservation of energy. So we can say that the card is moving with a speed of 2 meters per second, or with a speed v(o), and it has a mechanical energy before it stops and a mechanical energy when it stops. Now the mechanical energy before the spring is stretched is kinetic energy plus potential energy of the spring, and the potential energy of the spring is 0. The mechanical energy when the object stops is kinetic energy, which is 0, plus potential energy of the spring. So we can say that 1 over 2 mvo squared, it is equal to 1 over 2 kx squared. The 1 over 2 and the 1 over 2 becomes cancelled, and what remains is, since we want to find the x max, is that the x squared, it is equal mvo squared over k, so the x max is a root of this quantity, mvo squared over k. We can continue with some questions from past ATS exams, and one question is given here where we have a V initial and a V final, and we need to find what is the force that it is acting on the object. And we remember that because of the law of the impulse and momentum, the impulse J is equal to the change of momentum. This means that the force times delta T is equal to m V final minus V initial. We don't know the value of the force, but the duration of the collision is 0.03, the mass is 0.5, and the velocity final, carefully, it is -5 minus the velocity initial is +10. Direction is important. Even if he doesn't give us the value, the -5, we need to insert the minus ourselves in the calculation. So force times 0.03, it is equal to -15 times 0.5, so -7.5. So the force is 7.5 divided by 0.03. This is 250 Newton. The minus indicates that the force is to the left, or opposite to the initial velocity. We continue with another question from ATS exams where we are given a force and we need to find the change in momentum as a function of time. And we remember that the force is equal dp over dt, or that the change of momentum is integral of f times dt. So it is integral of 9t squared dt, and this is 9 times t to the power of 3 over 3, so 3t to the power of 3. Again, if I'm solving this too fast, please feel free to pause at any stage to read the question a little bit more carefully. Also, what we have here is a mass, and the ball is dropped into a steel plate and it bounces back. The initial velocity, that we know that it is 10 meters per second, and the final velocity we know that it is 4 meters per second. But since the ball bounces back, the second velocity will consider it negative. And now that we know this, it is quite easy to find the impulse. The impulse is equal to the change of momentum, and the change of momentum is m v final minus v initial. So 3 minus 4 minus 10. So negative 14 times 4, this is negative 42 Newton times second, or kilogram times meter per second. And the answer is D. Then we need to indicate what is the arrow that shows the change of momentum. We solved something similar before. The change of momentum is mass times v final minus v initial, but we need to remember that the change of momentum and the velocity are vectors. The final velocity is up and left. The initial velocity is up and right, so we need to subtract these two arrows. Again, in order to subtract two vectors, we need to change the minus into plus and flip the direction of the first vector, so we need to add these two vectors. So if I add them with the parallelogram way, parallel to the first and parallel to the second, we get the result that the vector is the diagonal of this parallelogram, and the answer is C. And we are given a force versus time graph, so most likely we need to find the area, and we need to show what is the velocity of the object if we know that the object moves with an initial velocity of 2 meters per second squared. Now we'll use again the impulse momentum theorem, and the impulse is equal change of momentum. In this case, the impulse, we will find it from the area under this graph, and the change of momentum is mv final minus v initial. The area for the first 3 seconds, it is half base height, so base is 3 and height is 6. The mass is given, we don't know the v final, and we know that the v initial is 2. So 18 over 2 is 9. This is equal to 4v final minus 8. We bring the 8 to the left, so 9 plus 8 is 17, is 4v final. And from this we find that the v final is 17 over 4, so 4.25 meters per second. And our last question on this topic, from a past ATS exam. We have a cart 1 that is about to collide with another cart that it is at rest. Now, this question in the past had more topics that are related to more of term 2 material, but we know that the force is given as a function of time, 3200 t squared minus 500 t. And from this, we know that we need to calculate the total impulse, and we remember that the impulse for a variable force is integral of f times dt. Now, this is impulse from the initial time according to the graph, it is 0, and the final time it is 0.16 of 3200 t squared minus 500 t dt. And if we insert this in the calculator, who will bring the answer 3200 x squared minus 500x minus 2 Newton times second. This is for part A, and for part B we need to find the speed of the cart after the collision. One way to find the speed of the cart after the collision is to say that for the cart 2, the impulse is equal to the change of momentum, so mass 2 multiplied by V final minus V initial. Now a little bit careful, the impulse on the cart 2 is negative 2, so the impulse of the cart 1 is negative 2, so the impulse on the second cart will be to the opposite direction, so the impulse will be plus 2. The mass 2 is 1.05, and the V final is unknown, and the V initial is 0. So the V final is 2 over 1.05. This will be just a little bit more, just a little bit less than 2. So it is 1.93 meter per second. If the question was about to find the final velocity of meter per second. If the question was about to find the final velocity of the cart 1, we would do the same application. It's just that the impulse would be minus 2 is equal m1 v final minus v initial. Minus 2 is equal, the m1 is 0.5, the v final is unknown, and the v initial is 3. And from this we would find what is the speed of the other cart. Again, feel free to comment or email me with your questions, and have a good day.